Hello, good morning, and welcome back to our second webinar series from Certara University. The focus of the second series will be on how to fit individual PD data. In this presentation, I will take you through two case studies. One, a sequential fit with PK frozen, and the second one, I call it as pseudo population estimate of PK from each individual. I would like to remind you that this is a 30 minutes express webinar, including a Q&A session. All participants are muted for this presentation, and please use Q&A panel if you have any questions. So my name is Chandramouli Radhakrishnan, and I'm based in Brisbane, Australia, and I'll be doing this presentation today. The webinar will cover four major steps. One, the sequential PKPD fitting. Two, how to freeze PK parameter. Three, fitting PD data, a pseudo population PK parameter, reviewing the results, and PD modeling. With case study one, which is a sequential PKPD fitting, where we have 6 animals were given an intravenous infusion dose of 5,000 microgram units over 60 minutes. PK concentration and associated PD response were measured over 24 hours for each animal. In the second case study, we again have 6 animals. On day 1, we have the PK concentrations measured. On day 2, a PD response were measured in 6 animals with a similar characteristics. So these are 6 different animals were used. This type of scenario could be common in some DMPK setup. The motivation in the sequential PKPD fitting, so what we are trying to do is a simultaneous fitting of PKPD data might not work as expected, as PD could influence the PK, and therefore it is best to fix or freeze the PK and use those to estimate the PD. Sometimes you have only PD data and you want to use the PK from a published or from previous study, but still do an individual fit. You could use what I call it as a pseudo population estimate with variability for the unknown PK. For the first case study, so we'll be performing the following steps. The first is fitting a PK model to individual concentration data, finding individual estimates for PK, that is volume and clearance, and then we'll be doing a PD fitting by freezing the individual estimates for PK and fit the PD data. And we'll be measuring the response for the PD data. The first step, in this case, what I'll be doing is just quickly looking at the data for my both PD and PK and PD responses. And I just want to show this graph for why to make sure I'm using an appropriate model. In this case, looking at the log graph, you could see a straight line, which indicates that this model could be better fit with a one compartment model. And also you could see the PD maximum response as an inhibitory response you could see at maximum concentration. So this could be a simple Emax model. From the observation data, the observed data, which can be sent to a Phoenix model, this you could do it by right-clicking on the data and use the send to option to Phoenix model and select the Phoenix model for running this particular exercise. as I mentioned earlier, this is a one compartment PK model with an option. I'm using a multiplicative error model, and I want to see the individual fit. Hence, I'm not selecting a population mode in this example. So when I do the PD fit, I could get a better fit of the data. And then the next step, what I'll be doing is using the same model and freezing the PK by selecting the freeze PK option. And I'll be using a PK Emax model, and I'll be mapping the parameter to PK estimates, and then we'll be freezing the PK and we'll be running the Emax model. So in this case, I'm using the baseline inhibitory and sigmoidal option for this particular example. After running the PD estimates, after freezing the PK, and I'm getting a very good estimates of my PD data. So I'll just quickly start with the demo of the case 1 study, and then I'll go and do the case 2 study later on. I'm just going to share my screen. Oh, can you see my screen, Anna? Is my screen visible?
We can see your screen, Mouli.
Yep, thank you. So this is my data for the case 1 study, where I have 6 individual animals, and the time is over 24 hours, and I have got the concentration and effect. I'm not going to go in detail about exploring, doing an XY plot for this data. So I'm just going to send this data to my model. So I've got the model here. I'm just going to drag my data in. And before that, I just want to mention the dose as well. I've got 6 animals. Each animal is getting a dose of 5,000 microgram and over an hour. So it's an intravenous infusion. And then I'm just going to drag my data in. And as I mentioned earlier, this is going to be a simple PK model, and I've disabled the population option, and it's an infusion, and I'm using a multiplicative error. And the dosing, I'm just going to drag my dosing table up here. So I do have sorted by the subjects with the dose A1 as mentioned, and A1 is going to be my rate, and the start time is mapped to time. And after doing that, I'll be just quickly looking at my initial estimates tab. So it's looking pretty good with my initial estimates with a volume of 66 and 1.5 liters for my clearance. And it's pretty much looking good. And I've accepted all my initial parameter. And just quickly going to run this option. This should take approximately a couple of minutes, less than a minute for me to run this model. It's being a simple model. And looking at my data, so I've got my theta value here with a good estimates for each an individual subject. And quickly going through the data set, I've got the individual fit for each subject, and I could see a good fit of my data. And so the next step, what I'm going to do is I could copy this model, can copy this and paste it, which I've already done it here. And then I'm going to use the same set of data for my PKPD options, and I'm just going to bring the theta table, which I've already done in this case. So where the estimates is mapped, I can do it again just to show you exactly what I've done. So, oops. So bringing the theta table and mapping my parameter and initial estimates, and the dosing table is being mapped. And what I'm trying to do in this case is just going to freeze my PK for individual animal, and I'm selecting a PK Emax model with a baseline at an inhibitory effect and a sigmoidal model. And quickly looking at my initial estimates for my PD, got the initial value set up already, and it feels I'm quite comfortable with the initial estimates. I'm accepting all the initial estimates and make sure it's being accepted here, and then I'm going to run the model. So quickly looking at my output, I've got a good fit for my PD model. This is one way of freezing your model, freezing your PK parameter, and finding the estimates of the PK PD estimates for your PD. And I'm just quickly looking at my theta value, and it looks good for me. And this is one way of representing your data. And then the second model, the second part, the second case study is going to be, sorry. It's the second case study is PD fit to pseudo pop PK. As I mentioned earlier, it's a 6 animal with similar characteristics as in case study 1, were dosed with the same drug, and only the PD data were collected this time over 24 to 48 hours. So the new data set will use the mean estimates and bounds from the case study 1 as a PK pseudo population model with variability. So the PK is not fixed to a mean, but instead it is allowed to range within the bounds in the case study 1. So that you'll be using the max and minimum of the theta value as a bound in this case. And then the second followed by simultaneously fitting your PK and PD. And PK is assumed to be, as I said, it's to be assumed to be the variable of each subject within the bounds. Under the map menu, PK estimates and bound will be using the min-max option. So quickly looking at my PD data set, you could see a good fit for my PD exploratory analysis. And the theta table for the individual animal, which I'm going to extract it from the first case study. And what I'll be doing is I'll be sending to a descriptive statistics to get the mean, minimum, and maximum value. The descriptive statistics can be seen under the option send to NCA and descriptive stats. It's pretty thing. And then I'm going to map my parameter tab with my descriptive statistics where I have time and descriptive stat where I'll be having an option for min and max as a bound for my PK study. So quickly going through the demo. Oops. Okay. So the first step, what I'm going to do is I'm going to send this data to my descriptive statistics to get the value PK estimates. So sending it to NCA toolbox, and we've got the descriptive statistics option here. I'm just going to put it in case 2. And all I need is my average, which is going to be a mean option. And then I'm going to have my min and max. And the parameter is the option I'm getting, and I'm just going to use the estimates. Oops. Maybe I can remove the log statistics as well. So, I've got my mean value for my clearance and volume with the min and maximum, which is going to be my upper and lower estimates, bounds for my upper and lower estimates, which I'm using within the model. And then I'm just going to send my study data to a Phoenix model. So where I have my ID mapped, and this is going to be a non-population mode, and I'm sorting it by ID, and then I'm bringing my descriptive statistics. Oh, sorry. So the dosing is going to be my dosing tab. It is an infusion possible. I'm going to choose a PK Emax model with a baseline enabled inhibitory and sigmoidal model. So sorted by a subject, start time, and you got the dose and the rate being mapped. This is another place to look if you, this will guide you if you are missing any options or if you are coming across any error. If you're running out, if you're running a model and it's coming with some error, this is the first place to look into. So I do have a few more things to be mapped. So I'm just going to go back to my main panel and then map my COPS. Just got EOPS and then mapping my C to COPS as well. And then the parameter estimates, what I'm going to do is I'm just going to drag and drop my descriptive statistics. So I'm having a mean as my initial value for my lower and upper bounds, which is going to be my min and max. So in this way, what we are doing is we are not freezing the PK parameter, we are not freezing the PK, and we are using the range within the animal to get a better fit of a PD. So once I've set up everything, I think it's pretty much good to go. This model is ready to run. We test it here. Okay, quickly looking at my theta estimates, seems to be all right. And going across the observations or the plots, diagnostic plots, just going to slightly change this one to look better. This can be done by double-clicking on the graph and on the y-axis, I'm just going to say auto scale the fit to the best. This is option you could do as well. That way, I get a better overview of my PK and PD responses curve. This could be done here. And overall, looking at my individual fit, it looks perfectly fine for me. And if you want to export for your thing, you could also change these options here to just go into y-axis and auto scale to the best. So it would give you a better look for your individual graphs as well. So overall, this is the other. This is another way of looking at your data, especially when you have two different sets of animal with same characteristics. On day one, you are doing PD, or you're taking this from a previous study where you have done your PK study, and then you're doing a PD after some time, and you could either you could go for your data from the literature or from any other source, or the other option is using the same data from the previous study, setting the bounds as a min and max. This is other approach which you could try, which you could use it as well. In summary, stop showing this one. Oops. In summary, if you have a PKPD data within an animal, you can do a sequential PKPD fit, that is by freezing the individual PK. And if you have a PK data for a group of animals and the PD data for a different group of animals, you can try using a pseudo-population approach to estimate your PK. Just let's finish off my presentation. If you have any questions, please do ask.
Hi, Molly. Yes, we have several questions coming in. Let me ask you the first question. The first question is this. Can you explain again why we're using bounds on case study 2?
Okay, sure. In the case studies 2, we are not freezing the PK parameter. So instead of freezing the PK to the mean parameter from case study 1, what I did was I put the bounds on the estimate, so they represents the population variability observed in case study 1. So which means I use the minimum and maximum of the estimated parameter from the first group of animals as the bound for those parameters in the second group.
Okay, thank you. There's another question about where can they find the recording for the first webinar, and I put that link in the chat. So if you're interested in seeing the previous recording, you have the link in the chat if you didn't get an email with that link. Also, there's another question also related to case 2. No concentration data was used, but the output showed concentration data. Where did the data come from? And I think it was just the way that that you did this demo, but let me just kind of try to explain this question. I think we were seeing a plot of concentration, but the idea was that you didn't have concentration, correct?
Yeah, so I just this is simulated data. I think you could I clicked the COPS as well. In this example, probably if I wouldn't have enabled that option, I would have just got the PD response. So I think by not clicking the concentration data, you would be getting just the EOPS, the PD parameter.
Okay. There's one more question here related to case study 1 is, can you show us again how the PK was frozen? If you go back to case 1 and show us where I can see what the PK parameters were frozen for each subject.
Okay, so I'm just going to share the screen. Oops. Screen 2. So up in the case study 1, when I did my
Molly, can you share Phoenix, please?
Yeah, can you see my screen now?
No, we see a PowerPoint.
Okay, hang on, share my screen. Coming up now?
Yes.
Okay, sorry. Okay, so when you select the model PKPE max model, as you can see in the structural tab, you should have something called freeze PK. This is where you go and freeze your PK parameter. You just click this option, freeze PK, that will freeze your PK parameter. So that can be checked up here. Can you see I don't have any options. I can't change any of my upper and lower bound, whereas with other parameters I could change for my PD parameter. So this is the other way of checking it. So it's mainly this particular box you need to enable it.
Yeah, can you maybe show us the initial estimates results that could explain maybe to this user? Yeah, so I guess here you can see that.
Yeah, you could see that for all subjects you have the typical volume and typical clearance being the same, which is 70 and 1.4 for all the 6 subjects, six animals. So this shows that the data is being freezed for the animal.
Okay, there's another question here that says, if we compare the models, which will be better?
So both the models could give you a better estimate. The second one, what you're trying to do is you're trying to give a bit more variability to the data rather than freezing the PK to the mean. You're just giving some variability within the animal by choosing an option of minimum and maximum. So that is, both models are good, and it depends upon what your expectation, what you're looking for. So in that way, I would say, both the models are good. And if you are looking for a bit of a variability, you could choose the second option. If you're not looking for any variability, I think you could freeze the PK and fit the PD data.
Great. We have one more question. I think we have time for one more question. Why didn't you fit the PKPD simultaneously in case 1?
Yeah, this is an option, and sometimes one can get better estimates, but that also means that PD can influence the PK. So if there is enough data for accurate estimate, it is best to fit the PK first and then freeze your PK parameter to estimate the PD part. So this is called a sequential fit.
Okay, great. I think that's all the questions that I have in the Q&A. I'm being told that maybe there were some questions put in the chat that I cannot see. Let me ask Dawn if she can see any of the chat questions, if there's one that she would like to ask. And if not, when we send the recording, we will send a Q&A from all the questions in the chat too, and we'll put it in a document for you to have. But let me see.
Yes, I do have a couple of other questions.
Okay.
The first one is, where are the minimum and maximum of the PK parameters being used? Isn't only the mean being used?
So if I'm just going to share my screen again. Hope you could see it. Up in the model, if you look at this, and I'm just going to the results and initial estimates. You could see this is my mean data, which is coming from my study 1. And this is going to be my low and higher bounds. This is my min and max, so which is coming from this particular case study. So this is where the data is coming from. So the theta value from the case study, I'm using it, the average as an initial estimate, and I'm giving a lower bound minimum from this data and the maximum from the same data set for between the animals.
And let me elaborate a little bit on that. So notice here that you're not freezing the PK. So if you froze the PK, you would only use the initial estimate there that would be frozen for PK. However, by not freezing the PK and allowing to have that estimate with a lower and higher bound, you're going to get the PK is going to have variability for each of these subjects. So we're not saying that we know the exact value for ID1 because we don't have PK. So we let it be within a range. And that's why Mo is calling this a pseudo population, because you use the understanding of case 1 of what you know, and you have that variability from the min to the max, and you let those estimates just be within those bounds. I hope this makes sense. Okay, this brings us to the end of the webinar, and we will address other questions in a Q&A document that we can put with the recording. So, Mouli?
Yep. And moving forward, from the Certara University, we do have a few more webinars coming up. The next webinar is on 13th May. This is by Dr. Berndt. He is going to talk more about rebuilding a population PK model from a literature references, and that is followed by another webinar in June, July, and August. So the whole presentation, for more information regarding population PK, you could refer to Certara University, and I would like to remind you until end of April, all the courses are free, and if you want to learn more about it, you could register at certarauniversity.com. Yeah, that's all about it. And thanks for your time. And yeah, I'll update the Q&A if I missed anything. Thanks for your time. Thank you.
Thank you, Mouli. We adjourn now.
Thank you.